Hello everyone. I am Vishwarup Das. I again come back to my channel Crazy Physics for my next lecture on the series of electronics. So in the last and the previous one, previous video, I had discussed about the mainly the number systems, which are most important thing about the digital electronics part. And I have shown some calculations, some operating number operations of 0 1 binary number system, octal number system, and hexadecimal number system. So right now, in this from this video, I will talk about logic gates. These logic gates mainly the application of the binary number application 0 and 1. So let's start the logic gates chapter from this video, uh, depending on the binary number system. Okay. So these are some properties of logic gates with example. Logic gates mainly the hardware implementation of a Boolean function. That means we have taught about the Boolean functions about that binary number systems. Those binary number systems will be implemented through some hardware, just like diode transistors, which we will come to the analog part, or the and the example. Those are the hardware things connected through a circuit diagram, and then the Boolean functions are being implemented by this hardware. Okay. And the this is we know that this is the logic gate, so there is some logic. There will be an operation that will input will be one or more than one logic inputs there, and those will produce a single logical output. And these examples are that the hardwares I have mentioned earlier, that diodes or transistors are the main hardwares for implementing the logic gates. Okay. And mainly in constructing the vacuum tubes, EM relays in optics, the logic gates are used. So next we will talk about what type of logic gates are there. So there are two types of logic gates are there. First one is basic gates and another one is universal gates. Okay, basic gates mainly are AND gate, OR gate and NOT gate. These three are the basic gates, and the universal gates are NOR gate and NAND gate. Okay, so NOR gate and NAND gate are just like when NOT is operating on AND gate, then that will be NAND gate. Not when NOT is operated on OR gate, then it will be called NOR gate. Okay, so these are the universal gates, and these three are the basic gates. So the operations are there. For AND gate, operations will be multiplication dot. For OR gate, the operation will be plus. Okay. And for NOT gate, the operation will be a equal to 0, a bar equal to 1, a equal to 1, a bar equal to 0. That means its operation will be like inversion. What type of input we will give, we will get the inverse of that input. Okay, so NOT gate basically used for inverter. There are other two types of logic gates there. One is XOR gate, another is XNOR gate. Okay, so these are the main types of logic gates are there. So the main thing about the logic gates is that their truth table. Okay, so truth table means that how the logic gates are working. So what happens is that we are implementing a circuit with using those hardwares like diodes and transistors, and then what we are going to do, supposed to do, then we are just make a circuit and get some logical outputs of getting from giving logical inputs. Okay, so there will be some operation of those type of logic gates, so their operation might be depend on their operation type. So AND gate, OR gate, NOT gate, and those NOR and NAND gates are so used to operate the logical things by giving inputs of logical input, and then we will get one logical output. So from that output we can be use some hardwares like about which how we have to want that to be behave. Okay, that instrument to be behaved. So these are the basic things. So let's we will describe about the operations and the symbols and the truth table. Okay, so we will now describe about the gates and their symbols with operation and uh, their truth table might be I will do there here. Okay, so truth table is like we will give inputs A and B and corresponding output will be Y. So A will be written as 0, 0, 1, 1. B will be written as 0, 1, 0, 1. Okay, so based on this kind of input, we will describe the operations and the symbols of the respective logic gates. So we will first try about AND gate. Okay, so for AND gate, the symbol will be just like this. Okay, so the inputs are there, A and B are the inputs, and Y will be the output. Okay, so its operation I have mentioned that it will be a product. So Y will be equals to A dot B. Okay, the multiplication of the inputs will be the output of AND gate. So for the input A and B both are 0, so 0 and 0 multiply will be output, we will get 0. Okay, 1 0 0, 1 0 0, 1 ones are 1. So this will be the respect that corresponding truth table for the AND gate. Okay, so next we will draw about the OR gate. So for OR gate, the symbol will be like this. So input will be AB and this is the Y output. So Y output will be A plus B. Okay, so if we do OR gate, we will go get the truth table like 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1. And what about 1 plus 1? In the Boolean algebra, if we add 1 plus 1, then it will give 1 0. Okay, so this is the sum, this is called carry. So the carry part will be here. Okay, so this one will be in the truth table of OR gate. So next we will do about the truth table of NOT gate. So for NOT gate, the symbol will be like this. Okay, so this bubble comes for inversion operation. Okay, so if we give input a and there is y is the output, then y will be a bar. So I have mentioned about the output of the NOT gate earlier, that if we give a is 0 and 1, y will be 1 and 0. Okay, and if we remove this bubble, then we will get another type of gate like this one. This is called buffer gate. This is not such important because in this, if we give some input, that input will be a output, so same as the output. So then for the buffer gate, the truth table will be like 0 0 1 1. Okay, so buffer gate is not such important thing. So next we will go for the universal gates, NAND gate and NOR gates. So for NAND gate, the symbol will be just like and the bubble, like this. A and B are the inputs, Y will be the output. So 0 0, this operation will be like A dot B complement. Okay, so 0 0 gives us 0. This that's implement complement will be 1. 0 1s are 0, that's its complement 1. 1 0 0 complement 1. 1 1s are 1, 1's complement 0. So this might be the, this is the this should be the truth table of NAND gate. Okay, so the next universal gate is about NOR gate. Its symbol is like same as OR gate but with bubble. A and B are the inputs and YB the output. Its operation is like A plus B whole complement. Okay, so 0 plus 0 0, complement is 1. 1 plus 0 1, 1's complement is 0. 1 plus 0 1, 1's complement is 0. 1 plus 1 is, I have told about that, carry 1 1, 1's complement is 0. So this is the truth table of the NOR gate. Okay, so the exceptional gates are there, some XOR gate and XNOR gate. So we will finally discuss about those truth table in this video. Okay, for XOR gate, the symbol will be like this, and its operation will be A vector plus B. Okay, so its truth table is like 0 0 0 0 1 1 1 0 1 1 1 0. Okay, so what might be its actual operation? If we consider this, this will be like AB bar plus A bar B. If B bar, A is 0, B bar is 1, 0 1s are 0. A bar is 1, B is 0, 0 plus 0 0. For similarly 0 and 1, 0 bar 1. Okay, so 0 0 1 bar 0, 0 0 is a 0, plus 0 bar 1, B is 1, 1 1s are 1 1. Okay, similarly for 1 0, that will give us 1, and for 1 1 it will give us 0. Okay, this is the actual operation of XOR gate. So for the final gate, XNOR gate, the symbol will be just like this, bubble will add up and the operation will be like this bar, and it will give another operation A vector product B. Okay, and this will be written as AB plus A bar B bar, and its truth table will be 0 0 is 1, 0 1 is 0, 1 0 is 0, 1 1 is 1. Okay, so these are the this video is about the truth tables and the operation of the logic gates. In the next video, we will further go about the logic gates and its operation and Boolean algebra. And if you want to get these notes, I will add my WhatsApp number to this YouTube channel description. Those who want to, you can contact me for this PDF. Okay. So thanks for joining this video. Hope we will for surely join for the next time. Thank you.